Hello friends, I hope you have understood the problem in the previous lecture. Here I am taking another problem which is you can solve by using the CR equation. And that problem is, so it's given as show that analytic function fz with constant magnitude with constant modulus of magnitude is constant. Okay. See that what kind of things are given to us. So let's say solution. Okay, what kind of things are given to us? First of all, f of z is analytic. This is known. This is given. Okay, this is given. Then what is given? Modulus of f of z is constant. Some c. Okay, c is a constant. So this is also given. These two things are given to us. Okay, and we need to prove that this f of z must be a constant function. Okay, fine. So we'll use this fact first. F of z is equal to c. Fine. So what? Since I say f of z is always u plus iv, you know that. What is modulus of fz? It is under root of u square plus v square. So this is equal to c as given. Therefore, if we square both sides, we'll get u square plus v square equal to c square. Okay, let us differentiate this equation with respect to x partially. So what you will get is 2u dabba u by dabba x plus 2v dabba v by dabba x equal to 0. Fine, derivative of c square is 0. So 2 can be cancelled. So you will have u x plus dabba v by dabba x equal to 0. Similarly, okay, so suppose if I call this as 1, differentiate 1 with respect to y partially, what you will get is u dabba u by dabba y plus v dabba v by dabba y is 0. Okay, now see that here I can now use the CR equations. Why? Because it is given to me that f of z is analytic, right? Okay, so I am going to use now this CR equations over here. So I'll call this as equation number 2 and equation number 3. Okay, fine. So I say that since fz is analytic, therefore CR equations are satisfied. Okay, so what are the CR equations? That is dabba u by dabba x is equal to dabba v by dabba y, and dabba u by dabba y is minus of dabba v by dabba x. Okay, so if we use these equations in these equation number 2 and 3, okay, these equations will change. Okay, now how these are changing? So see, so equation number 2, I am using this fact. So from 2 we can write, see, this part I am keeping as it is, u dabba u by dabba x. Now dabba v by dabba x can be written as minus of dabba u by dabba y. So this is minus v equal to 0. All these as 4. Is it all? It is see vx I have replaced by minus of uy, and from 3 we can write so this I am keeping as it is. Okay, and now see that vy can be written as ux. Okay, so I have used CR equations and I have changed these second factors with this one. So I have got the equation number 4 and 5. Okay, now I am squaring 4 and 5 and I am adding. Okay, so square 4, 5 and add. Okay, why we are doing this? We'll come to know. So if we square and add, what we'll get? So u dabba u by dabba x minus v dabba u by dabba y. I have squared this plus u dabba u by dabba y plus v dabba u by dabba x square equal to 0. Right? Okay, so we have opened these squares now, right? So this get cancelled. Now if you look at these two, we can take dabba u by dabba x square common. So what we'll get is into bracket, this is u square plus v square, right? Plus from these two we can take again dabba u by dabba y square common. So we'll get u square plus v square. So from these two terms, if we take u square plus v square common, okay, we'll get u square plus v square in one bracket. In another bracket, we'll have dabba u by dabba x bracket square plus dabba u by dabba y bracket square. Right? And now this is equal to 0. Fine. Now see that if u square plus v square itself is equal to 0, see this is the product and the product is equal to 0. Okay, so one of them has to be 0. So if we take u square plus v square to be 0, so if, okay, then what will happen? These are two positive quantities because they are squares and their addition is 0. So this implies u equal to 0 and v equal to 0. So if this happens, your given function f of z is 0 and that is constant. So we will achieve our result. So if u square plus v square is 0, we will definitely achieve our result. So let us assume that u square plus v square is not equal to 0. Right? Then what will be 0? Then this bracket has to be 0. Okay. So then dabba u by dabba x bracket square plus dabba u by dabba y bracket square has to be 0. Again, both are positive quantities, their sum is 0, so they must be individually 0. So this implies dabba u by dabba x is 0 and dabba u by dabba y is 0. Right? What do you mean by this? This implies u is constant. Okay. Similarly, by considering the other way around, we can show that v is constant. So whatever we have done with dabba u by dabba x and dabba v by dabba u by dabba y, same we can do with dabba v by dabba x and dabba v by dabba y, and we'll get v is constant. Okay, and therefore f of z, which is u plus iv, Okay, so we have proved this result, that if the modulus of f of z is constant and f of z is analytic, the function has to be constant. Okay, I hope you have understood this problem. This is a very important problem as far as your exam is concerned. Okay, so you can solve some more problems in the exercise. Okay.